Hi everyone, welcome back to NotesNaka, and in this video we are going to be solving this problem, distribute candies. It is an easy level problem and I chose this problem because in this problem we basically get to learn how we can write different codes for a single problem. So I will not be exactly writing both the codes, but I will tell you the process and how you can figure that out. So what does this question tell you? Alice has n candies where ith candy is of candy type I. Alice noticed that she started to gain weight, so she visited a doctor. The doctor advised her to eat n by 2 candies. So basically we have to find out the number of candies, different types of candies she can eat still following the doctor's advice. So in this example we can see there are total 6 candies. So 6 by 3 means we have 3 candies that she can eat. Now we have to find how many different types of candies are available there and if she can eat all the different types or not. So basically we can see 1, 2 and 3. So we have 3 types and she can eat 3 types. So we have to print 3. In this example we can see we have 3 types of candies, but she is only allowed to eat 2 candies. So what will be the output? The output will be 2 because she is only allowed 2, so she can eat 2 different types. In this one we have only 1 type of candy, but she is allowed to eat 2 candies. So how many different types can she eat? She can only eat 1 different type because there is only 1 type of candy she has. So this is what we have to do in this question. So we are given a vector, this vector over here, and we have to first find out how many different types of candies are there. Now there are 2 ways to find out that. One is using a hash table and another by sorting. So if this is sorted, you can just traverse through each and every and count the different types. How did I count the different types? So I have a count 0. I first sorted it and then I have a count 0 and I started with 1, that means from this index, and then I just checked if this element is equal to the previous element. If it is equal, then just increment the I. But if it is not equal, like if I is over on 2 and then I minus 1 is 1. So 2 and 1 is not equal, right? So at that time we increment count and also the I. At the end, so this will count, the count will give us 2. So at the end we just increment 1 because it won't count the last different candy. So we have count is equal to 3. Now after that we just see if count is greater than candy type size by 2. That means if it is greater than 6 by 2, then return 6 by 2 3 only. And if not, if count is less, then we just return count. That is how much she can eat. So this is the way doing using sort and not using a hash table. But so if we do this, the time complexity will be more. If we use a hash table, then the time complexity will decrease, but the space complexity will increase. So I have used sort and it got accepted like this as well. So you can see this is accepted, and if I submit, this is also accepted. It is faster than 90.13%. So maybe if I use memory, and the memory is less than 91%, right? So I didn't use a hash table, so it is less than this much percent. But if I use it, use the hash table, then what would I have to do? I would make a hash table. So in the hash table, we can see hash table, I would store these numbers. So what will be stored? 1, 2 and 3 would be stored. Then I will find the size of that hash table and then just do this part will remain same. So that is how you will use a hash table. So this was the video for today. This was the problem that I chose, but from tomorrow onwards I will be choosing really good problems. If you have any suggestions, then please leave it in the description. I will solve that problem first, and otherwise I will be just solving really most asked interview questions in FANG and other places, and try to give a really good solution, most efficient solution in C++. If you enjoy this concept or would like to come along with me, then please hit the like button and also subscribe to the channel, and I will see you again. Till then, take care and bye bye.